taking a look at 4.5 here. Our last two ways to show your triangles are congruent. Before we get there, start with a quick review. Taking a look at what's given here. So first off, we are given that AC is congruent to DC. And we are given that CB is an angle bisector. All right, so right now we have three different ways we can try. Side, 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 angle, side, and HL. Right now we have one set of sides to work with. The other thing they tell us the other thing that we should always look for, all right, I gave us a little checklist of three things. Are there parallel lines? Well, in this case, no, there's not. Do you see the X so that we have vertical angles? In this case, we don't. Do the two triangles share a side? Well, here they do. So I can do CB is congruent to CB. As for our reason, that's our reflexive property. So now I got two sets of sides. So now we either need the third set of sides, being AB is congruent to BD for some reason, or I need the angle in between those sides, being angle ACB and angle DCB. So if I look at the other piece of information, this is where we got to be careful. They say that CB is an angle bisector. So it's not a segment bisector. It's not bisecting our segment here. Right? Instead, it is now bisecting the angle, cutting this angle up here in half. So that does give me that angle ACB is congruent to angle DCB. As for our reason, that is our definition of an angle bisector. Now we do have our two triangles congruent. Triangle ACB is congruent to triangle DCB. As for our reason, we just showed SAS. So getting to our last two then. Our first one is going to be known as ASA, angle, side, angle. Once again, remember the order is going to be important. So here notice the side is in between our two angles. Right, so that side is the side that touches both the angles that are marked. So angle A is equal to angle D. AC is equal to DF. And angle C is equal to angle F. That makes triangle ABC congruent to triangle DEF. Right, so that's what ASA would look like. Your other one then is going to take that side and it's going to shift it outside your angles. And in this case, it does still work. Your other one is angle, angle, side. Notice how now the side is outside of your two angles. So it is not in between them. It only touches one of those angles. It does not touch them both. So we still have angle A is equal to angle D. Angle C is still equal to angle F, but now my sides change. We're looking at BC being equal to EF, making triangle ABC, once again, congruent to triangle DEF. So we now have 5 different ways to show your triangles are congruent. There's your checklist, 3 things to always look for. Look for that reflexive property, your parallel lines. Specifically, you're looking for your alternate interior angles. And look for those vertical angles. Anytime you have that X there, even when your lines are not parallel. So here, any other markings we can add in. There's no parallel lines. They don't share a side. They do have vertical angles. So I do have all 3 sets of angles marked. But I do not have any sides. So this is still going to be a no. In your next one, they do share a side, so I can put a mark on it. There are no parallel lines. There are no vertical angles. So right now I have 2 sets of angles, and then I have a side that is not between them. So it is yes because of the angle, angle, side. In my next one, they do not share a side. There are no parallel lines. I do have that X though, so I can mark my vertical angles to be congruent here. In this case, we now have our two sets of angles and the side that is in between them. So this one is yes because of angle, side, angle. All right, take a look at your overlapping figures here. We have the 60 degrees with 60 degrees, and some people may struggle to see this at first. So if it helps you to take your two triangles apart, they want to know, are these two big triangles here? So there's our one. Is it congruent to this triangle here? So I'm going to pull these two triangles apart and redraw them. So I have the 60 and the 90, the 60 and the 90. So I do have two angles, congruent to two angles. But I need one of my sets of sides to be congruent. If I go back to my picture when they're together, one of the things we have to look for, and this is a different way to show it, do your two triangles share a side? And here they do. They share this side, TW. So I can say that TW is congruent to TW. It just looks a little bit different. Right? They overlap each other and share that side instead of butting up against each other there. But it's still the same idea. I can still say that TW is congruent to TW. So I can put my mark. And it is yes. As for your reason, I have two angles. And now the side that is not in between them. Right? Looking at what we can add in, they share that side, so TW is congruent to TW. My right angle with the right angle. So we still have two sets of angles and the side not between them. So it is ASA. Right? And then there's your homework here.